All right. Do you guys remember Brett's lawns and car washing business? You guys remember
I thought
that?
we were done with that.
No, we're not done, Brett. It's easy if I keep coming back to things you understand.
I thought he died.
Do you guys remember Brett's lawn and car washing business?
He died.
Yeah, no, he didn't die. Okay. Remember, he broke his hand and he cut his hand. He didn't die though. All right. So what was the equation for Brett's lawns and car washes? What was it? How much money did he want to make? 1,200, right? How much did he charge for 15 for car washes, right? And how much for lawns? 20 for lawns.
It was 10 for cars. It was 10 and 15.
Was 10 for cars?
Yeah, it was 10 and 20.
Oh, okay, it was 10. Last time I was wrong, they said it was 15.
No.
Okay. So he charges 10 for car washes and 20 for lawns, right? Now, this was the goal that he wanted to make. That's what he wanted to make was $1,200, right? Right?
Yeah.
Can you guys find solutions to this equation? Can you guys find solutions?
It's 15 and 20.
It is 15?
Yeah, 15 for lawns, 20 for cars.
Okay.
That was 10 and 20.
All right.
I know I tried this
15 for cars, you mean?
No.
one.
15 for lawns, 20 for cars.
Is it really?
Looking at
Yeah,
the book right
I'm
now.
looking at the book.
Let me check my notes then.
You were wrong this whole time, Nicholas. We did not say that.
We didn't say that. No, I did 15 for lawns and 20 for... Wow, it is right in there.
I should be so specific.
Oh, you know what we did though?
What?
I think we did 20 and 10.
Yeah.
Because we did 2A. We didn't do number 1. Rebecca, you are correct. But we're going to go 20 and 10. Okay? All right. Rebecca, you are correct.
I know, but that's how we were.
I know, you're mad at me now.
Yeah.
All right. So now, what's one way I can solve solutions? I can pick one and solve for the other, right?
Right.
Right? So I pick one and solve for the other. We're going to get some L values and some C values. All right? If L is 0, then C is going to be 120. If C is 0, then L is going to be 660. Right? You guys remember that? Okay. We could also solve this for... We can also solve this for... Given y equals 4 right long? Okay, we can solve for what, Faith? We can solve for what? L or C, doesn't matter, right? If we solve for C, we end up with C equals 120 minus 2L, right? And if I plug that in my calculator, I get a big table of solutions, don't I? Possibly. How many solutions are in that table? All the whole numbers. Would you say there's 10 solutions and only 10 solutions? No. 20?
No.
30?
No.
Okay, would it be a reasonable amount to say there are at least 60 solutions in that table? Okay, what do you think, Lon? You give me a number. A lot, okay. We'll quantify a lot as 60, is that okay? Okay, good. So, there are a lot of solutions I can get by plugging this into my calculator and looking at that table, isn't there? Okay. Now, the one thing that we didn't consider here is there is a limit to the number of days of summer. Phineas and Ferb, tell us how many are there.
104 days.
There you go. 104 days of summer vacation, right? So Brett only has 104 days, right? Right?
Yeah.
Now, let's say his parents make a stipulation. They want to make sure Brett has a good time still in the summer. So they make a stipulation that he can only have 85 customers. Okay? We're going to say, so his parents say, Brett can only have 85 customers. Okay? So that means he can only have 85 transactions. I think Brett has 2 keys in
Can
there.
I get paper
That says
towel?
Brett.
I don't have any.
Oh,
You can go to the bathroom washing. Okay? Or bring your trash can here. Alright? I need to get some from the office. So let's say Brett only has 85 customers because his parents don't want to use all 104 days on mowing lawns and washing cars. You know, they want him to go out and try to, build time machines and stuff. So how would this change our equation? Is it going to change this equation? Or is it going to add a new equation? It's going to add a new one. Right? Jamira, what's that new equation look like? What's it going to equal? What's by itself? 85. Right? What else? 85 equals what? 20L. Okay. Plus 10C. If you're using pen, don't write that down. Okay. Does one lawn mowing count as 20 customers? No. Does one car wash count as 10 customers? No. Right? So since that's the case, this 20 makes it look that way, right, Rebecca?
Yeah.
Okay. One lawn mowing is only one customer, isn't it? Right? One car wash is only one customer. These 20 and 10, that's how much he makes per lawn mowing and car washing, right? So how should this be?
We have to solve like how many lawnmowers and how many car washes to equal up to 85 customers.
Right. So what should I do this equation? Is this equation right? No. What needs to happen to it, Jamira?
L and C.
The L and C, do I keep the variables or do I change the numbers in front?
Change numbers in front.
Okay, what should they be?
Do I just make up any number?
Nope.
To equal
Okay.
85?
The L and C are we're going to plug into equal 85, right? But a lawn mowing and a car wash only counts for one customer, right? Right? So it's just 85 equals L plus C. All right? Does that make sense?
Yeah.
Yeah, because one lawn mowing is just one customer. One car wash is just one customer. So 85 equals L plus C. You guys see that?
So it's kind of like the one in front of the L.
Yeah, there's a 1 in front of the L and a 1 in front of the C. Perfect. Because each one only counts as 1. Right? Does that make sense? Yeah. Now I can find tons of solutions to this. Right? L and C. If L is 85, what's C going to be? If L is 84, what's C going to be? 1. If L is 83, what's C going to be? If L is 82, what's C going to be? 3. Right? If L is 81, what's C going to be? 4. We could do this 81 more times, couldn't we? Sound like a fun time? You guys ready for this?
No.
Okay, good. Me neither.
Yes.
All right. But what I'm trying to get at is there is a very large table of solutions to this equation, right? And there's a very large table of solutions to that equation. But what we need to do is we need to find what satisfies both of them. Now, how many combinations do you think will satisfy this equation and this equation?
One.
1? You guys think Long's right? Is it just 1?
2.
Now you're backing off that long? It's 2 now? What do you guys think? 1, 2, 10? Who thinks one solution? Raise your hand. One solution. Who thinks one solution? Who thinks there's 2 solutions to both equations? Who thinks there's 3 to 7 solutions? Just arbitrarily pick 3 to 7. Okay. Long you can't vote for them all. Okay. Who thinks there's 7 to 10? Who thinks there's more than 10? Okay. Long, always go with your first gut reaction.
Alright.
There is one solution. There is only one combination of L and C that'll make both of these equations true. Okay. And that's what we need to find. We need to find that one combination that makes these 2 equations true. Okay. So how can I do it? I have 2 tables. What do you think I should do? Find one that's equal in both. Okay, there's 86 terms to this table we talked about. There's Long said a lot, and we quantified a lot as 60, right? There's 60 terms, maybe more, to this table. And that's not even counting possible decimal answers, right? Because if I start going to decimals, even though they don't make sense in the context of the problem, they still might be a solution, right, Jessica? If I start looking at decimals, that means there's millions of possible answers to each of these tables. Do we want to look through millions of entries in tables?
Yes.
You do? Okay. If you find that exciting, then this class should be like watching a movie for you. Okay? A little more exciting than looking at tables. At least I hope I am. All right? So, what can we do? Okay. This is called a system of equations. A system of equations is when we have when we have 2 or more equations that model a system, model a certain situation. These two equations model our situation. Brett wants to make $1,200. He charges 20 for lawns and 10 for cars, right? His parents say he can only have 85 customers, right? We're modeling a real-world situation with two equations, right? And if I'm going to solve this system, that means I need to find the solution or solutions that keep them both true, Ethan. Okay. Now this is a linear system, so there'll only be one solution. There are quadratic systems and exponential systems and power and third power systems and fourth power and so on. And those will have two or more solutions depending on the powers. But this one only has one. So a system of equations. First off, let's figure out what that is. A system of equations is two or more equations with two or more unknown variables. Okay. I look at Brett's situation. How many unknown variables do I have? Two, L and C, right? If I have two unknown variables, how many equations do you think I need? Two. If I have three unknown variables, how many equations do you think I need? Three. If I have four, how many equations? Four. You need as many equations as you have unknowns. All right? Now in this class, we're going to focus on two equations and two unknowns. Okay? So we need two equations to solve for two unknowns. Need two equations to solve for two unknowns. What does solve mean?
Find the solution.
The solution, how many are there, did we say?
One.
One, okay? So solve means to find the solution that satisfies both equations. Now when I say satisfies both equations, what does satisfies mean? Fits, right? Makes them true, right? These numbers all make this equation true, right? 84L and 1C. That makes this true, doesn't it? Right?
Yep.
0L and 120C makes this equation true, doesn't it? I got to find the solution that makes both equations true. If I do 84 and 1, will that make this equation true? No, because I'll have 1680 plus 10, right? Does that equal 1200? No. Okay. So I got to find the one solution in this case that satisfies this equation. Okay. And sometimes there'll be more than one solution, but we're just going to focus on ones that have one solution. Now there are three ways we can do this. Rebecca, got a question?
No.
Okay. There are three ways we can do this. The first way is substitution. Okay. And that's what we'll learn today. The second is graphing. Hello, when you're intuitive. Intuitive. It means that you search for answers. Graphing is the second way. And the third one, which is my favorite, personal favorite, elimination. They all require algebra. Well, it won't be math class when we're doing algebra, right? It'll just be number theory or something.
I don't understand. I'm never going to use this in my lifetime of living.
You'll be surprised.
I'm pretty sure I wouldn't. I'm never gonna.
So let's say you have a situation similar to Brett's, right? Let's say that you have 104 days of summer, for example, right? And you need to make enough money to pay for your college tuition. Okay? You get paid $100 a day at one job and $75 a day at the other job. You like the $75 a day job better, so you want to only work there as much as you can. Okay? Let's say your tuition is $40,000. Okay? Just throw a number out there. So 40,000, right, equals 100 at one job, we'll call it A, plus 75 at the other job. Call it B. You have 104 days. How much do you have to work the 2 jobs in order to make your tuition? System of equations. All right? Does that make sense? So, yes, you might not choose to use this, but there are ways you can use this in your life to make it be able for you to find out how things are going to work out. Okay? So there are ways you can use this. All right, are there any questions? Joining it with me? Yeah? Okay. Hey, you're not going to say, are you filming this? Yeah. All right. Are there any questions before we go on? Okay, so you guys ready? We are going to figure out how to solve a system using substitution. All right? Josh, you excited? You can see it in your face, man. You are super excited. You got your pump up music going, right? Getting hype.
He has a playlist.
Got a playlist for math.
Yep.
Is it got like a Pink Floyd on there? No one is the zone. You need to do some YouTubing. All right. Solving solutions by substitution. I just write subs because you guys know I can't spell. So solving solution by substitution. Or solving a system. Oh, it should be solving a system by substitution. Solving solutions by substitution? I know, but now I got a system. That doesn't rhyme as much. It is alliteration, though. Okay, so solving a system by substitution. Now, as we go through this, I'm going to write the steps in black. Okay? And I'm going to write what we do in the steps in a different color. Okay, I'll probably use blue for that. I'll probably use blue and green because it gets boring if I just use black the whole time, right? No, it's not. Okay. Now our system is 1200 equals 20L plus 10C and 85 equals L plus C. That's our system. Okay. Now, anytime in mathematics you see a bracket next to 2 equations like this, that means those 2 equations are tied together somehow. All right. Those 2 equations define our situation. Okay. So that's why I put a bracket around them, because they define the situation. So, on your notes, put a bracket. The easiest way is to draw a forwards S and a backwards S. Easiest way, forward S, backwards S. Works out. Now my first step is to pick an equation and solve it for a variable. Pick an equation and solve for a variable. It doesn't matter which equation you pick. It doesn't matter which variable you choose. Now, most definitely, there are ones that will make your job easier, but it does not matter which one you pick and which one you solve. So if you ever get a system of equations and you have to solve it using substitution, just pick an equation and solve for a variable. Okay? Ethan, you look like you need to get involved. Which equation you want to pick? Top one or bottom one? Top one. Okay? Now, when you're doing this step, you want to choose wisely because you want to start off with something that's easy. All right? So, Ethan, which one do you think is easier to solve, the top one or the bottom one?
Bottom.
The bottom one. The bottom one has no coefficients on our L and C, right? Right?
Yeah, the top one has.
Top one has lots of coefficients, right? So the top one we're going to have to divide. We'll have to divide with the bottom one? No. So we could easily use the top one if we want to. But I think the bottom one is easier. So that's where I would start. Okay? Now, Ethan, do you want to start with the top one or bottom one? Which one do you like?
What did you say you like that?
I like the bottom one myself because it's easier, but you can pick. I said you could pick. No, I want you to pick.
Top.
The top one, okay.
Why?
Okay. 1200 equals 20L plus 10C. We need to solve this for a variable. Which variable would you like? L or C? L. So we're going to solve for L. Okay. We're going to solve for L. Now, solve for L means I need to get L by itself, right? Right, Maddie? Okay. What's my first step in solving for L, Maddie? Oh, Jamire helped you out. What is it, Jamire? Subtract not just 10, but 10. Okay, 10C. So I'm going to 1200 minus 10C equals 20L. Now, can I combine the 1200 and the 10? No, because one has a C, one doesn't, right? Okay, here you go, Maddie. What's my next step now? Divide by 20. Perfect. Now we divide by 20. 1200 divided by 20 is 600. 10 divided by 20 is.
Wait, why can you all of a sudden divide 10 by 20 when they have different variables?
Because division you can do it doesn't matter what variable I have, you can do it. You can only combine, you can only add and subtract like terms. You can divide and multiply anything you want. Okay? Good question. Bruno?
It's 60.
It's 60? Thanks, sir. Another reason why I like to record in front of you guys, so you catch my errors. I don't just waste the whole video. Alright, so 60 minus what? What is it? Thank you, Tony. Like 5C equals L. Right? So there we solved for L. Okay. First step done. Nice job.
First step.
Yep. 15 more to go, Josh. Why are you guys so excited about this? You didn't hear my joke. 15 more to go. Not really. Okay, number 2. Step 2. Okay. And this is where it gets its name. Okay. Substitute the results of the previous step into the other equation okay. Let's point this out now. The result of the previous step, right? That's right here. Okay? This is the result from the previous step. Okay? The other equation. That's right here. This is the other equation. Okay? Oh, thank you. Yep, I meant the other one. That would have been fun. Not really. This is the other equation. Okay? Last hour we started with the bottom equation. That's why I got it mixed up. Alright? So that's their equation. So substitute the result of the previous step into the other equation for the variable we solved for. Ethan, you with me? Okay. So what that means is I take 85 equals L plus C. Okay? 85 equals L plus C. And I know from step 1 that L equals 60 minus 0.5 C. Right? Since L equals 60 minus 0.5 C, that means I'm taking this 60 minus 0.5 C and I am plugging it in right there for that L. I am substituting it in for that L. And that's where we get the name. Now when I substitute for that L, we get 85 equals 60 minus 0.5 C plus C. Let me say that again. We get 60 minus 0.5 C plus C. What do we now have? 2 C's. Do we have anywhere else? No. We can do. What can we do with those 2 C's? We can combine them. And once we combine them, what can we do next? We can solve. So now we've taken an equation of 2 variables and turned it into an equation of 1 variable that we can now solve. So you guys have done all the hard work now.
Yay.
Everything after this is easy. Okay? Everything after this is algebra and plugging in numbers. Okay? Step 3. solve the results from the previous part. Oh, I'm going to use step. Step sounds smarter than
Oh my god, there's 3 steps to one thing.
Oh, we're not done yet.
I thought we were like on elimination already.
No, this is still substitution.
What? You're lying.
No.
I know. It's gonna take a paper just to answer one question.
No, that's why these problems are so fun.
If there was one problem, maybe.
Way smaller.
Okay, so what is my first step? Combine like terms. What are my like terms? And negative 0.5c, right? So what's 1c plus negative 0.5c? 0.5c, right?
Oh, it's a negative.
Yep, negative 0.5 plus 1 is 0.5. Okay. It's like saying you have $1 but you owe me 50 cents. Yeah, assuming you pay me back. Alright, so now what do I do?
Then you divide by, then you subtract 60.
Subtract 60, good. 85 minus 60 is? 25. Equals 0.5c. What do I do now? Divide by 0.5c. Oh, not 0.5c, just divide by 0.5, my fault. 0.5's cancel out, 25 divided by 0.5 is? 50. So how many cars does Brett have to wash? 50. Okay. And some of you can probably say, well, easy. I know how many lawns he has to mow now.
Did you plug in 50 for the other
Can plug in 50 into what equation?
The second one?
The second equation. Okay. So the last step, the fourth and final step, is to take the result from step 3 and plug it into either equation, okay, this one or that one, okay, and solve for the other variable. Okay. So step 4. Take result from step 3. Okay. This result is right here. Oh, that's a terrible arrow. Okay. Take result from step 3 and plug it in to any, actually, let me say anything, to either of our first equations. And solve for the remaining variable. Ooh, lots right now. So to do that, which one, I can pick either one to use, right? Which one is going to be easier, the 85 or the 1200? 85. Okay. So 85 equals L plus C. We know C is 50. 85 equals L plus 50. What do we do now? Subtract 50. Oh, we get 35. So in order to meet his income goal of $1,200 and satisfy his parents' requirement of only 85 customers, Brett needs to wash 50 cars and mow 35 lawns. And there you solved your first system of equations.
Super easy.
It was not years, that was minutes. Okay? Now, guys, if we look at all the steps though, I know all together looks intimidating, but every step is something you know how to do. Right? Step 1. Step 1 is rewriting y equals mx plus b form. That's all it says. Rewriting y equals mx plus b form. You know how to do that. Okay?
Back to my question.
Step 2
Use this in my life.
is substitute in, right? And combine like terms. You guys know how to do that. Step 3, find the variable, solve an equation. Step 4, plug it in and evaluate. It's all 4 steps that you guys know how to do already. Okay? Are there any questions? Josh, can I record here? Sure. Okay. And then you guys can see that one better. We are about done with class, so that is where we'll end today. All right. Do not forget this.